Let's check out this problem that'll help you get ready for the AP Calc exam together. If you want to try the problem on your own, go ahead and pause the video now. Otherwise, let's go ahead and try it together. Now keep in mind that when you see this sine to the -1 of x, this is just another way of saying arc sine of x, or the inverse sine of x. So if you prefer it, you can write it like this. If you've managed to memorize the derivatives of inverse trig functions, you can actually solve this pretty quickly. The derivative of arc sine of x is just 1 over the square root of 1 minus x squared. So whatever you see over here where x is, that's going to be substituted in the bottom down here. That being said, we don't have anything really complicated in this problem. We just have this x that's in our inverse sine function. So we can go ahead and say that the derivative of this arc sine of x is just going to be 1 over the square root of 1 minus x squared. Then all we have to do is take this x and substitute in 1/2 for it over here. If we do that, we're going to get 1 over the square root of 1 minus this 1/2 raised to the second power. Now if you go ahead and look at our answer choices, this looks like B, right? And that'll be our answer. Now if memorizing isn't really your thing and you just want to kind of know where this comes from, let me go ahead and show you now. Let me see if I can convince you that this over here on the left is equal to this over here on the right, using some things that you've already known. Alright, to start, let's go ahead and just define that y is going to be equal to arc sine of x. Now, if you go ahead and take this equation and take sine of both sides, sine of arc sine is going to cancel out on the right side, and we're going to get this equation that sine of y is going to be equal to x. Now let's go ahead and take this equation and implicitly differentiate both sides. Now on the left side here, if we go ahead and take the derivative of sine of y, the derivative of sine is going to be cosine. So we're going to have cosine of y, but because we have an inside function here, we should go ahead and use the chain rule. We're going to also have this dy dx afterwards, okay? And then afterwards, we're going to say on the right side, the derivative of x is going to be equal to 1. Now to get this dy dx alone, if we go ahead and divide both sides by cosine of y, we can go ahead and say that this dy dx is going to be equal to 1 over cosine of y. Okay, so at this point we have dy dx, which is the derivative, and we know that this is going to be equal to 1 over cosine of y. So this actually kind of looks like this a little bit, right? So the only weird thing left is, how do we know that this cosine of y is the same thing as the square root of 1 minus x squared? So that's where you're going to have to reach way back and think about your trig identities a little bit. Does one of the Pythagorean trig identities ring a bell? Hopefully you've seen this trig identity before, where we have sine squared of x plus cosine squared of x is equal to 1. For our purposes, we're going to go ahead and use y for a variable instead of x. Now if we solve for cosine squared of y and subtract sine squared of y to both sides, cosine squared of y is going to be equal to 1 minus sine squared of y. Next, by taking the square root of both sides of this equation, we can go ahead and say that cosine of y is going to be equal to the square root of this 1 minus sine squared of y. Alright, so at this point we see that this cosine of y is the same thing as the square root of 1 minus sine squared of y. So let's go ahead and substitute that in over here. If we go ahead and do so, we can go ahead and say that the derivative would be equal to 1 over the square root of 1 minus sine squared of y. Alright, so this denominator is starting to look a lot more like the denominator we want over here, but how do we figure out that this sine squared of y is the same thing as x squared? Now remember from over here that we said that sine of y is equal to x for a moment. So if we know that sine of y is equal to x, and we see this sine squared of y over here and sine squared of y, what's that? Sine squared of y is really just equal to sine of y multiplied by sine of y, right? If that's true, we must be able to say that sine squared of y is equal to x squared. And that's pretty cool because we can go ahead and take this sine squared of y is equal to x squared, substitute that in over here, and we can actually figure out that this derivative does make sense. This is going to be 1 over the square root of 1 minus x squared. This checks out. So while that's a bunch of behind the scenes work, if you want to go ahead and just memorize this in the future, feel free to do so.